All right, we're going to continue using operations with radical expressions. In this case, we're going to practice with the distributive property because we're going to have parentheses. So we would use this the same way we did before when we were learning how to use the distributive property. I have a number that's being multiplied outside of the parentheses, and I'm going to multiply that by every term inside the parentheses. We're just, also including the radical sign now. So I'm going to take this square root of 2, and I'm going to multiply it by each piece. So the first one is the square root of 7. And so I have square root 2 times square root 7, and then I'm going to go square root 2 times 12. So I have plus square root 2 times 12. So now I'm going to simplify 2 times 7. Since they're both radicals, I can multiply, and I get 14. I cannot multiply the 2 and the 12 in this case. I have to leave them separate. I do squish them together just like I would with, coefficient of a variable. But I can't actually multiply and get 24 because one's a radical and one is not. Okay, so be careful about that. If you can simplify your radical after you've done your multiplication, then this would be your next step, although 14 can only break into 2 and 7, and neither one of those are squares. So at this point, we're done. That's it for that one. So for the next one, they're not showing you both of the binomials, but this square means that there's 2 of them. We are squaring this. So this is what it looks like if I, instead of writing a little square, if I write 2 of them. So I have the square root of x minus 2 times the square root of x minus the square root of 2. I forgot to say square root of 2 on the first one. So we can use this one, and I think what I'm going to do on the PowerPoint here is go through FOIL. I know when I'm doing this on the board, in class sometimes I go through the other methods. There's the vertical, horizontal method. There's the box or area method, depends on, your teacher what they call it, but I call it the box method because you use a box. So it just kind of depends on preference there, but I'll go ahead and use the FOIL method on here. So you go first, so x squared times x squared, outside, which is x squared, sorry, I don't know why I'm saying squared, square root of x times the square root of 2. So, and it's negative 2 on here, so I brought the negative with it. Doesn't mean I'm subtracting, I'm multiplying by negative square root of 2. And then I have negative square root of 2 times square root of x. I keep wanting to say x squared. I don't know why. So here is that second one, and then the last one. So this is inside and then last. So we call it FOIL simply because it stands for first, outside, inside, last. Just kind of reminds you of how to multiply. It is by no means the only way to do this. So the last two I have are negative square root 2 times negative square root 2. So let's go ahead and start kind of simplifying this a little bit more. Remember, anytime I multiply a square root times itself, then I'm going to end up with a square that I can take the square root of, which is the number I'm multiplying. So square root x times square root x is just x. For this one, I have the square root of x times negative square root 2. So I'm going to put the 2 and the x together. X times 2 is 2x. But I have to make sure I bring that negative down because that negative is in front of the square root of 2. And then I have the same thing on this one. They're just flip-flopped, but it's the same thing. It's negative square root of 2 times, just square root of x. So I get negative square root of 2 times x. And then the very last one, I have 2 negatives, so it's going to make a positive. And square root 2 times square root 2, well, that's that same idea. If I multiply them by themselves, it's just going to cancel out the square root. And again, this one's a little easier to think about, I think, because you have 2 times 2 is 4. The square root of 4 is 2. So same thing with x. X times x is x squared. The square root of x squared is x. So whenever you're multiplying a number by itself, or a radical by itself, it's just going to come out to be that one number. Kind of cancels everything out there. All right, we have one more piece to simplify on this one because we have some like terms here. I have 2 identical radicals, 2x and 2x, so I need to combine them. So remember, there's a 1 in front of here. That's what I'm combining. So I have 1 here and 1 here. I'm going to add them together because they're both negative, so I add and keep the negative sign. So I have x minus 2 square root of 2x plus 2. And sometimes there's a little line over here. My program wasn't doing it, and I just didn't feel like putting a little line over every single one because that would have taken me a long time. But a lot of programs do extend the line over, so you can see that it's over the entire term. All right, so there's one more piece here. So we have this one. These were identical binomials, so it was a square, right? With this one, this is what we call a conjugate because they're opposites. Other than the plus to minus, they're identical, okay? So it's just a different pattern. that we can go through and recognize. But we're going to do the same thing. So we're going to do FOIL. So here's first, I have 2 square root of x times 2 square root of x. And then I'm going to go outside. So that's from, outside to outside, in case you weren't sure what outside meant. 2 square root of x times negative square root of 2. Remember, don't forget to bring that negative. All right, now I'm going to do this next one. So inside, I have square root of 2 times 2 square root of x. And then last. So square root of 2 times negative square root of 2. So here we have that. All right, so let's clean this up a little bit. So we've remember when you're doing this, because I know it's a little busy looking right this moment, but focus on, one piece at a time here, and the pieces are separated by addition or subtraction, not negative signs. Be careful with that one. Okay, if it was actually subtraction, then that would be fine, but this is being multiplied, and it's just a negative 2 being multiplied. So I have 2 times 2 is 4, and x, the square root of x times the square root of x, remember, that's a square root times itself, so it's just x. Now I have 2 times negative 1, and then x times 2 under the square root. And now I have square root of 2 again times x, and the 2 is in front, but this time it's a positive because there's no negatives in this one. It's just a positive. And now I have square root 2 times square root 2. Well, that's going to cancel. Remember, that's just going to be 2, but I do need to pay attention since it's a positive and a negative. It's going to be a minus 2. So one last piece here, we need to simplify. We can combine those like terms in the middle here. So I have negative 2 square root 2x and positive 2 square root of 2x. Anytime I have a number minus itself, it's going to cancel out. This middle term completely cancels. I have negative 2 here, I have positive 2 here, that's 0. And I, of course, drop a little dot here when I actually type it in. So it's just 4x minus 2. That's it on that one. That's always what happens with the conjugate binomials. The middle term will always cancel out. So that's actually the pattern that you can notice. The middle term will always cancel out. And if you noticed on the previous page, so when I square a binomial, the middle term is doubled. So it's both 2 and x, and then it's doubled by being multiplied by 2. So a couple of patterns to notice there. All right, so that was distributive property with the radical expressions. Hope that helped, and I will see you in the next video.